Welcome back to The Explainer. Today, we are exploring a truly fascinating and radically different perspective on Earth's history. We're going to unpack a core component of the Unified Theory of Geologic History, or UTGH. This catastrophist framework proposes something completely outside the bounds of traditional geology. It argues that a subterranean, mineral-loaded superocean once existed deep beneath the Earth's crust. And the water inside it? Well, it didn't behave like any ocean we see today.
I want you to imagine a scenario that literally defies everything you intuitively know about how water behaves. What actually happens when water is trapped under miles of solid rock, heated far beyond its boiling point, and squeezed by an incomprehensible 40,000 atmospheres of pressure? Well, according to the UTGH, it becomes the most aggressive, extreme solvent imaginable, and that setup sets the stage for a planetary-scale event that the theory claims left chemical signatures we can still see all around us today.
Okay, let's dive into this. Here's our roadmap for today. First, the extreme solvent. Second, the subcrustal chamber. Third, hypersonic release. Fourth, geodes and native copper. And finally, brine pools and salt domes.
All right, Section 1, the ultimate extreme solvent, understanding UTGH.
To really grasp this theory, we first have to completely abandon our everyday understanding of water and look at the fundamental physics of extreme environments. The UTGH framework proposes that the water beneath the crust wasn't a normal liquid, and it wasn't steam either. It existed in a totally distinct phase of matter called supercritical water. You see, when you heat water above 374 degrees Celsius and apply more than 220 bar of pressure, it crosses a critical threshold. In this state, the distinction between liquid and gas completely ceases to exist. It just becomes this dense, highly energized fluid. We often call water the universal solvent, but in this state, that moniker takes on a terrifying new meaning.
Now, water is known as the great solvent. But why is that moniker so far more appropriate for the supercritical water that was released in this event? Well, normal surface water is oxidizing, and it's actually a famously poor solvent for silicate minerals. It just doesn't easily dissolve solid rock. But under these extreme conditions, water's dielectric constant drops dramatically, meaning its electrical properties fundamentally change. It becomes highly ionized and chemically aggressive, easily dissolving silicate minerals and crustal rock right into itself. It literally becomes the ultimate extreme solvent.
Moving on to Section 2, inside the subcrustal chamber 60 miles underground.
So where was this crazy solvent hiding? The framework calculates that this pre-flood chamber sat at a staggering 1,280 to 1,430 degrees Celsius. That is hot enough to melt rock. It's far, far beyond the normal boiling point of water. Yet it didn't boil. It couldn't. It was physically trapped by the immense weight of the 60 miles of granite and basalt sitting directly on top of it.
That layer of rock created 40,000 atmospheres of confining pressure. At 40,000 atmospheres, a vapor transition or boiling is physically impossible. So the water just sat there, absorbing thermal energy from the Earth over geological ages. And because it was in that highly ionized supercritical state we just talked about, it dissolved a massive inventory of crustal minerals, salts, and metals. We're not just talking about hot water here. It was a dense, highly pressurized chemical soup absolutely loaded with the dissolved building blocks of the Earth's crust.
Which brings us to Section 3, the hypersonic mineral release, the rupture event.
This is the breaking point. The author of the UTGH, Darrell Waters, describes the catastrophic violence of this moment perfectly. He writes, "The decompression was not a release, it was a detonation. This wasn't a slow leak or some geyser bubbling up. It was a planetary-scale phase explosion occurring simultaneously along tens of thousands of miles of a global fissure."
Let's walk through the actual physics of this catastrophic decompression. According to the model, a fissure opened along what is now the mid-ocean ridge. Instantly, that 40,000 atmospheres of pressure dropped to surface levels. All that stored elastic compression energy converted to kinetic energy in a flash. The supercritical fluid underwent an instant phase transition, launching this dense mineral-loaded fluid upward at speeds calculated at 47 to 93 kilometers per second. To put that into perspective, that far exceeds Earth's escape velocity. It would have blasted this ultimate solvent and its dissolved rock directly into the atmosphere and literally out into space.
All right, Section 4, geodes and native copper. Let's look at the physical evidence.
So, what physical evidence does the framework claim was left behind? Well, the author points directly to the American Midwest. Take the famous Lake Superior geodes. These are agates found in the cavities of basalt rock.
Now, the standard model suggests these voids filled slowly over millions of years through groundwater percolation, but UTGH argues that these voids wouldn't even survive millions of years without collapsing. Instead, the framework proposes they were rapidly injected with the silica-rich, high-temperature subcrustal fluids expelled during the rupture. The voids filled instantly, right before they could collapse, capturing the exact chemical signature of the deep Earth like a snapshot.
We see a really similar argument with the massive native copper deposits of the Queen Peninsula. Normal surface groundwater is oxidizing, right? So it creates oxidized copper ores. But the Queen copper is native copper, meaning it's found in its pure, unoxidized metallic state. This requires a highly reducing environment, one completely starved of oxygen. The UTGH framework notes that this perfectly matches the signature of the deep, reducing supercritical fluid that was expelled from the chamber. It essentially acts as a chemical timestamp of the event.
Finally, Section 5, Brine Pools and Salt Domes, Post-Flood Anomalies.
But what about the rest of the planet? I mean, all that dissolved salt had to go somewhere. The immediate aftermath of this planetary detonation was an ocean heavily loaded with dissolved salts, metals, and subcrustal minerals. The global background was simply a much, much saltier, more mineral-rich ocean than had ever existed before. And this specific baseline set the stage for some of the strangest geological anomalies we see in our oceans today.
Let's move on and see how this builds into the modern day. To explain this, the author proposes a very specific three-step formation mechanism. Step 1. Centuries later, an ice age lowered sea levels, restricting certain ocean basins and causing massive evaporative concentration. Step 2. This extreme salinity precipitated out as solid beds of salt on the seafloor while deep liquid brines pooled in the lowest trenches. Step 3. As the ice melted, lighter freshwater flooded back in, stratifying on top of the dense brines and preserving them flawlessly at the bottom of the sea.
And according to the framework, we see the results of this exact process all over the globe today. Think about the massive salt domes in the Gulf of Mexico, which trap our modern hydrocarbons. Or the Red Sea brine pools, like the Atlantis 2 Deep, which sits at a staggering 257 practical salinity units. For context, normal ocean water is only about 35. Even the deep, incredibly salty layers hidden at the bottom of the Yucatan cenotes. The UTGH model unifies the origin of all these extreme, isolated environments under one catastrophic chemical release, subsequently concentrated by the Ice Age.
The absolutely crucial point here is that these underwater lakes of brine survive to this very day because of hydrodynamic isolation. Their density is so extreme that it acts as a physical barrier. The normal ocean water sitting right on top of them simply cannot mix with them. They are essentially time capsules, holding the concentrated, evaporated remnants of the ultimate extreme solvent that was blasted out of the crust thousands of years ago.
It's a breathtaking way to look at the world around us, isn't it? By entirely rethinking the physics of water under extreme pressure, the UTGH framework attempts to unify everything from pure copper deposits to underwater brine lakes under a single catastrophic mechanism. It really forces us to ask, if this alternative lens is correct, if an extreme subterranean solvent really did reshape our world, what else might the Earth's chemistry be hiding in plain sight? Thank you for joining me for this explainer, and keep asking questions.